Welcome back. Now that students have explored the concept of least squares in part 2 of this activity, we return to the problem at hand, which was modeling fire spread. Part 3 of this activity is short, and you can anticipate that students would only spend about 10 minutes on this part of the activity. While this Canvas course is focused on the GAZE recommendation to integrate real data with a context and purpose, one of the other GAZE recommendations is to look for ways to provide students with experiences that allow them to practice multivariable thinking. Part 3 of this activity is an opportunity to do this by considering the effect of a third variable. Because there are a number of different variables that affect fire spread, this context is a great place to give students practice working with more than two variables. In the previous part of this activity, students looked at data on fire spread rate and wind speed for a fixed fuel moisture content. The experiment that produced the data also looked at other fuel moisture contents, 4%, 8%, 12%, and 16%. In parts 1 and 2, the data was just for the 4% fuel moisture content. Here, students see the data for all four moisture content levels plotted on the same graph. One way to begin is by asking students how many variables are represented in this graph and what they are. There are three variables represented: fire spread rate, wind speed, and fuel moisture content. This is a good place for a short whole class or small group discussion where students comment on what they notice when looking at this new graph. The discussion of what students notice about the new graph that introduces a third variable should lead to a consensus that the relationship between fire spread rate and wind speed doesn't look to be the same for all of the moisture contents. Noting that the relationship between fire spread rate and wind speed is different for the different moisture contents is a good lead-in for a whole class or small group discussion of whether it makes sense to fit a single line like the one shown in the original scatter plot. You can wrap up this part with a discussion of what to do instead. One possibility is to create a different linear model for each moisture content. Another strategy that may not occur to students but that is worth mentioning is that it's possible to develop models that incorporate both wind speed and fuel moisture content into a prediction equation. If you cover multiple regression in your course, you can revisit this data later to show how that is done. If not, you can just point out that multiple regression could be used to do this, but that it's something that would be covered in a later course. If time allows, you can spend a little time exploring the strategy of fitting a different line for each fuel moisture content. You can show students the equations of the four different regression lines and note that the lines have different slopes, suggesting that the effect of wind speed on fire spread rate is different for the different moisture contents. Increasing wind speed is associated with greater increases in fire spread rate when the fuel moisture content is low. It's also worth pointing out that predictions based on the individual lines would tend to be more accurate than predictions made from a line fit to the entire data set, as they can see by looking at the original plot. This wraps up our discussion of part 3 of the fire spread activity. Next, we have a few questions for you to think about. Off you go.